My name is Hiro Okuge. I work for Kubota for 17 years, and I do a lot of service as well as sales in the West Coast, the regional manager. And but yeah. Let me go to the MBR basics, and then after that, I will go to the troubleshooting. And so let me cover these things as a basic things. So let me start from the term called TMP. What is TMP? Has everybody heard the word TMP? This is going to be maybe going to be a quiz that have some at the very end, and so please remember. But TMP stands for transmembrane pressure. It's the differential pressure between front and the back side of the membrane during filtration. So if you have, let's say, a straw with a little like a filter at the top of the straw, at the end of the straw, and when you're sucking with your mouth, the water, if the filter at the very end of the straw is very fouled, you have to suck very strong. You have to suck the water very strong. And so when the TMP is high, that means you have a lot of pressure loss at the membrane. So it's a very important index that indicates the membrane fouling. And so the pretty much only thing you have to kind of watch on your scatter screen is TMP at your MBR membrane plant. So this is one plant TMP, so when we operate our membrane, there will be a cycle of on and off. Typically, we filter the membrane 9 minutes on, and we have 1 minute of relax time. And so we stop the permeation for 1 minute while you're keeping the blower still on. But in this case, this is a little, the TMP was increasing in both MBR tank number 3 and 4. And you can see this is 1 hour trend. Gradually, the TMP was increasing. And so I was called on Friday night, went down to this plant on Saturday. Was trying to help, but the TMP was basically increasing with multiple storm event that happened at this plant. But when the TMP is rising like this, then you might be worried a little bit or be cautious and make sure that it will be stable a little bit more than, it's not like inclining like this, but it should be a lot more flat and stable. So what does that TMP increase means? It sometimes does mean, it does mean that membrane is fouling more, or if you're having a higher flow rate, the TMP is going to be higher anyway. But also the air that can be inside the permeate per piping line can cause a higher TMP because it's a lot of loss. The sludge conditions can make the TMP a lot more higher. Higher mixed liquor means higher viscosity, and it's going to be more like a chocolate, and that could cause a higher TMP as well. Low filterability could also cause higher TMP. Sometimes the return rate could be a little bit lower than what it should be, and it could cause the high mixed liquor, eventually high viscosity, eventually a little bit of higher TMP. Kevin was calling me, but Kevin, sorry, I'm not sure if you joined or not, but since you kind of dropped off, I started this this session anyway. Sorry about that, but you can maybe jump in and follow up afterwards, or yeah. And then air scouring. If you have an issue at the diffuser, let's say all the diffuser is clogged, you can eventually start fouling the membrane. And the other fouling material like calcium or inorganic fouling materials, or even organic fouling materials like just organics, can build up on the surface of the membrane. So these will cause TMP increase, and when they do a troubleshooting, we'll check these things one by one. Yeah, so this is just the schematics. The sludge can, be a cause of higher TMP. A lot more permeate flow can cause it. Any airlocks can cause it. Actual membrane fouling will, of course, cause the TMP increase. If you lose the air, definitely you will have TMP increase. So it's good to keep all these, 4 conditions balanced. So let's go with the flux rate. What is flux rate? If you have operator certificate testing at some point, maybe you might want to know what this flux rate is. But the flux rate is a flow rate that goes to a certain square foot of membrane surface area. So the unit is a gallon per square foot per day. That means if you have 1 square foot of membrane, how much of gallons of water that goes through this 1 square foot in a day. So you use something like 10 GFD, 15 GFD, 20 GFD. That's a very common terminology in this MBR business, and yeah, we use a flux rate. That means basically, yeah, flow rate per square foot. Now, this is another screen from the same plant that I showed. We did a lot of troubleshooting at this plant, but so the flow rate is shown on the blue and TMP is on the orange. But if the flow rate is higher, this TMP in the orange is a lot higher. The flow rate go to the low flow, the TMP would also go low flow. So as you can see, yeah, if you have higher flow rate, flux rate, then you have higher TMP as well. When the temperature is also low, the flux rate is typically a little bit lower. And so that's another aspect of flux rate. Okay, let's go to the next word, permeability. What is permeability? If this is an in-person workshop, I would ask everyone, but I do apologize. This is online, so I can't really have this interaction very well, and that's the tough part of this online workshop. But permeability is a flux divided by TMP, because if you have flux rate or flow rate higher, the TMP is also higher. So TMP itself sometimes doesn't indicate the fouling itself, because if you have higher flow rate, flux rate, you have higher TMP. And so we try to divide this flux rate by TMP and try to identify where the membrane is on a term called permeability. So 1 psi of pressure, how much flow rate can we have? That's the permeability. So let's say our flux rate is 15 GFD, and if we have about 1 psi of TMP, permeability would be 15 divided 1 psi. So it's going to be about 15 GFD per psi over here. So if you have lower, like 0.5 psi of TMP and 15 GFD of flux rate, you're going to have about 30 GFD per psi. Now, after chemical cleaning, some plants start from very high. I know some plants start somewhere between 50 to 100 GFD per psi, and it just gets a little bit more stable around 30, 20, somewhere around 20 to 30 at most of the plants, I think. And the reason is that TMP starts at around 0.3 psi, 0.2 to 0.3 psi. And then, yeah, gradually, when the TMP increases, the permeability will come lower and lower. So some plants, I know that you judge the timing of chemical cleaning by looking at the permeability, and if the permeability gets too low as about 10 GFD per psi, or some plants around 15 GFD per psi, they do some kind of chemical cleaning. I think there's a reason for that, and I'll talk a little bit when I talk about the chemical cleaning. But chemical cleaning, typically when you typically you do it when the TMP increases about 0.5 psi up to 1 psi from the original starting point. That means the permeability can drop somewhere close to 15 or 10 in that range in most of the plants. So, but every plant have a different trend, trend. So, you know, we will respect what you have at your plant, and it's not just, this is, I'm just talking general textbook things. You know, you could please follow your plan. You know, if you're always doing it a little bit more higher range, please keep on doing it. Some plants start a lot more lower from the beginning, so chemical cleaning timing is based on your plant. Typically, you do it when the TMP increases about 0.5 to 1 psi. Permeate set flow set points. We have high flow, medium flow, low flow, and then when the flow is no flow, we have an intermittent mode, or sometimes we call it nap mode, taking a nap. But yeah, when there's no flow, it's intermittently, you know, it aerates every 60 minutes or 30 minutes for 5 minutes to keep the bugs alive, but that's intermittent mode. Permeate cycle is we have typically the plants are 10 minutes of frequency, and you have 9 minutes on for permeate pump and 1 minute off for the permeate pump. We call that time a relax. The blower will continue operating during that relax and knocks off some of the heavier fouling on the surface of the membrane. Okay, so the next one is my favorite word, mixed liquor. You know, you're not hearing? Okay, something happened. Not sure why you're not hearing. There you go. Okay, not sure what's going on with my screen. Do not. Do you hear me now? Diego or Taz, do you hear me?
Hey, Hiro, we're having some issues with the audio, and so I've told people to go ahead and use the phone connection to be able to listen to it. For some reason, your computer audio isn't coming through.
Oh, okay. So where did I stop? Kevin?
No, I think you're fine to continue from your mixed liquor favorite word discussion.
Okay. Did I lost the previous slides?
No, it's weird. Some people are hearing you and some people aren't. And so for those who can't hear Hiro, please use the phone call option to be able to listen. For those of you that have computer audio, just continue to use that.
Okay. Well, then I'm going to continue. Okay, well, let me just continue then. Yeah, so mixed liquor, you know, this is one of my favorite words because I'm going to give you a quiz of what this mixed liquor means. Mixed liquor is not this. You know, sometimes, you know, I'm originally from Japan, and when you go to Japan, you start from the beer, you have some wine or Japanese sake or whatever, and you mix all the liquor in your stomach. So this is the definition of mixed liquor. I'm just kidding, but this is the place where everyone laughs when the workshop is in person. I can't hear you, so I do feel a little bad, but this is not the true, you know, this is one part, this is a mixed liquor, but we're talking about the sludge, mixed liquor suspended solids, not the mixed liquor in your stomach. Typically you want to you know, make it somewhere around 8,000 to 12,000. Again, it also depends on the plant. You want to keep it maybe lower than 15,000, higher than 5,000, but you know, some plants higher than 8,000. If you have really, really low food, some plants operate a lot lower, like 5,000. I know Abandoned Dunes in Oregon operates around 3,000, but their BOD is always super, super low. So it depends on the plant, but typically a lot of plants operate somewhere in between 8,000 to 12,000. Okay, so next one, filterability. What is filterability? We have a special, like, well, it's not very special, but we have an origami class sometime, and we fold the paper filterability, paper for, we typically use Advantic 5C filter, but we use the filter, and then we take a sample of 50 milliliter of mixed liquor, and we pour it on this folded paper, and then we take 5 minutes and see how much of the water coming out. If it's more than 10 milliliter, it's okay. It's recommended to have more than 15 milliliter at least. A lot of plants have more than 20 in a healthy plant, and so the higher, it's a lot better, and it's easier to filtrate. So we don't use sludge settling process like a conventional plant, but we use this filterability to check how easy the sludge is to filter. This is just to indicate it only takes 5 minutes. It is recommended to do it once a day or a couple days a week, so that you will know the sludge condition, how the sludge condition is. So when you do troubleshooting, one thing I would ask is, what's the filterability of your plant? And so it's good to check this. If you don't know how to do it, we can always, when our service guys visit your plant, we can show you how to do it. Please let us know. It's very important testing that we standardize throughout the whole world. For any MBR plants around the world, we do this filterability testing. Air scouring. Air scouring is a very important aspect as well. You might want to have a certain SCFM for your membranes. You can talk to us of the right number for your plant. We have multiple series. We have like 16 type of series. So this is just an example, but yeah, we can calculate your SCFM that is required for your plant. High airflows, you can increase the cleaning efficiency a lot more, but it's a little bit more stressful through the membrane. Air pattern. You might want to see an even air pattern, so, not just one big burst at one place and no air at the other ones, but you want to see an even aeration from the diffuser. You know, this plant, you have a little bit more burst at some points compared to the others. I would like to show you the video. Can you guys see my screen? You can see that one part is aerating and this part is like some part not aerating. So what we did was we lowered the water level to the top of the membrane cassette and aerated and saw which part was aerating and which part was not aerating. So go back to this presentation. Yeah, there was some part aerating, some part not aerating. You might want to check if the air is distributed evenly throughout the whole cassette. In this case, we took the membrane cassette out and we put the water right above the diffuser branch pipes. So the water is right above the diffuser, and we put the blower on, and you can see one part is aerating and one part is not aerating. When you do over air, like if you have a big burst of air in one place, that place can have a high vibration, and a crack happened in the past where we had a very, very strong air. You can't underestimate the strength of the air. There's a lot of stress. Now, if you don't have an air, you will start seeing some of the sludge accumulation in between the plates. So air is a very, very important aspect of our MBR operation. So how do you want to keep those diffuser cleaned? We have a process called diffuser cleaning for some of the cassettes. Some of the later models, we won't have this process. If you have a membrane called SP, we wouldn't have this. But older cassettes, we have a valve called membrane diffuser cleaning valve. And if you open these valves, this is connected to the air line. And what happens is, if typically these are closed, but when you open it, what happens is all the air from the blower will go to this diffuser, but it won't go out of the diffuser, but it will actually suck the water into the air pipe, and it will flush the diffusal line, and it will prevent from some of the water and sludge that comes into the diffusers with the air being very hot. It could dry up and make a clog inside this diffuser. So you want to flush this diffuser like once a day. So this is one example of diffuser cleaning valve and a little like cyclone air, release piping, but the sludge is just going to come out from this. This is another plant. The sludge is going to come out. If you open the diffuser, they have openings at the very bottom of this place so that it won't splash too much at the very end. But some plants they'll just have a pipe discharge at the very end. When the plant is having a manual diffuser cleaning valve, not automated, you want to open this valve. But when you open these valves, you have to please make sure that the permeate pump is stopped. So manually, you stop the permeate pump. If it's a gravity plant, you got to shut down the permeate valve, and then you just open this valve manually. You keep the blower on, and that's it. And you do this for somewhere between 2 to 5 minutes a day, maybe a couple times a week. If it's manual, maybe if you can do it every day, that would be great. But if you cannot, a couple times a week will be fine. But please make sure to clean these diffusers. If it's manual, this is the process. Just stop the permeate, open the valve. That's it. If you have automated diffuser cleaning system, just on the scanner screen, just enable diffuser cleaning function in a system, and you just have a set point at least once per day. At certain time, you keep this on for 5 minutes, and it will be automatic. And if you have automatic setting, it would automatically close that permeate line. So please don't worry about shutting off the permeate line when you do this. It will be automatic. Physical diffuser cleaning is something you may not want to do, but it have happened in the past at some plants when a lot of rags or sludge, the heavy sludge or grids build up at the very bottom of the diffuser. Sometimes it blocked the diffuser, and we had to clean these diffusers manually. Now these diffusers can be taken. If your plant is old, newer than 2010, I believe most of your plant will have this detachable diffuser, so you can detach this and clean it, or you could have a little like spray washer system that can wash inside this tube to clean those diffusers. This is me in a plant in Tennessee. It's a plant called Pigeon Forge, but I went inside the tank and you know, with the Tyvek suit on. This is me. I look good before I get down into the tank. But after I get into the tank, this is how I looked like. You know, we had those kind of fire department right next door at the wastewater treatment plant. And a lot of people came to save me if I have something happen. It's part of, I think it was their kind of like a training as well, but you know, they had some safety people with a fire truck just in case at that city. I asked if they wanted to come in, and they said, well, if something happens to you, we'll jump in. Some of the tips, this is just, if you do this, don't wipe your face with your hand or with your Tyvek suit, because you're gonna have an issue if you wipe your sweat. I couldn't wipe my sweat, and my sweat, you know, it was summertime in Tennessee. It was pretty hot, and some of the sweat came into my eyes, and I wanted to wipe so bad, but all these, you know, my hand and my Tyvek suit, everything was super dirty. I couldn't wipe anything. I had to let just my sweat get into my eye, you know. So anyway, don't eat the sludge when you clean it. You gotta put your mouth shut, so that when you splash with the water, those, you know, splash back of the sludge won't come into your mouth. Don't just make sure you close your mouth. If you don't want to do this, call us. We'll get in, do it for you, you know, together with you, hopefully. But no, we do it all the time. No hesitation. One thing, if you call us and let us do this, please let us use your shower. Pigeon Forge, we had a nice shower, and I really appreciate it. But you know, we want to, you know, help you guys. The ultimate goal is to help you guys. It is, you know, these membranes are made in our factory. We know who exactly makes this. We have a heart for our product and for your plant, and we really want to help you guys. So that's the bottom end. You know, please call us. We want to help you. If you need us to clean together, we'll do it. You know, we'll try not to eat the sludge, but yeah, if you need to go through this stuff, you know, it's not gonna, this is like more on the emergency case. Most of the plant doesn't go through this. Every maybe 5 years they have to do this, but you know, it's a wastewater treatment plant. If you have a heavy lot of grits coming into the plant, and if you collect the sludge diffusers, or if you have, this plant actually had a lot of fibrous material at the very bottom of the diffuser, and the diffuser was pretty much clogged, and so we had to take all that fibrous materials that was built up, and I felt like I was doing a heavy lifting, you know, because all these fibrous material was so much volume at the very bottom of the tank, and it was very heavy, but anyway, yeah. Yeah, if you don't have this issue, no worries. But if you have to do the diffuser clean with a physical clean, yeah, just please do it, or please call us, or yeah, yeah. If it's necessary, these things could happen. It's better not to happen, but just make sure your fine screen have a good capture rate and is well maintained. The next one is CIP. What is CIP? You know, we use the word CIP pretty often. It means clean in place. It's an in situ chemical cleaning, so we don't need to drain the tank. No need of draining the tank. We just backfill the chemical, and you know, you do this when the TMP increases for about 0.5 to 1 psi from the original starting point, or maybe every 6 months, even if TMP is stable. So that's about the frequency, and you backfill the chemical. So I mean, a lot of places have a eductor system now, but we back inject the chemical, and we leave it for 2 to 4 hours, and for most of the time with sodium hypochlorite. And so for any organic fouling, and most of the plant have organic fouling, and so most of the plant will go through sodium hypochlorite, about 0.5 to 0.6% for 2 to 4 hours. I know some plants do overnight soak when the flow rate is lower. When the mixed liquor is very, very low, you could try a little bit lower concentration as well. When you have inorganic fouling, some of the industrial water, wastewater have inorganic fouling. Also, if you have alum injection or ferric chloride injection or PAC injection or any of those phosphorus removal chemical reaction in your plant using alum or ferric or PAC, those are inorganic fouling material. So I would recommend using either oxalic acid or citric acid, 0.5 to 1% for 1 to 2 hours. If you have a lot of calcium, I know some of the dairy plants have high calcium in the effluent. In those cases, I know it's a little bit dangerous and sensitive to use it, but the plant needs to use hydrochloric acid for cleaning those. Some of the plants in Idaho does this. Please don't use oxalic acid for calcium wastewater. It's gonna mix up and make another scale. So for a sodium hypochlorite, we will typically you buy a tote of 12.5%, then you'll mix that 25 times, and it will end up 0.5%. You have 12.5%, mix it, dilute it 25% with the water, you can end up having 0.5% of sodium hypochlorite. So some plants I know that they do 20% dilution, 20 times of dilution instead of 25. That's okay. It does make it up to somewhere like 0.6, a little bit higher, but and if you want to do 0.25, you need to dilute by water with 50 times. So that's the CIP system. The membrane lifetime and durability. At the very end of the lifetime, we will typically have a physical breakage of the sheet and the plate itself, but there is a lifetime on the membrane. I haven't really seen much of unrecoverable fouling that happen. A lot of foulings are recoverable. It's more of a physical breakage at the very end of the lifetime. So membranes are exposed to aeration. So it's aerated, 24/7, 365 days, years and years. The membrane will get weaker and weaker. And what happens is at the very end of lifetime, at the very corner of membrane or wherever it is welded to the plate gets the most stress with the air vibration. And so we have a testing called membrane tensile strength testing. We pull off the membrane sheet and we compare the strength of this pulling compared to the new membrane. And if the strength is less than like 40% of the new membrane, it's time to replace. If the strength is between 40 to 60%, it's time to start budgeting. So this is the strength test result. This plant shows pretty good strength even after certain years. This yellow line is the line that this is a result from a plant in Oregon, and this was tested in 2016. We had one data that was showing less than 60%. Most of them were still in the 80 to 100. I told them, hey, there was one data that was a little less than 60%, but I think you can keep operating. They operated for another 2 years. And in 2018, we had a lot more data set points that this is the same plant that was a little bit lower than 30%. And they replaced the membrane in 2019. So we'll do this testing for free at any of the plants if you request. So please let us know if you want to do this testing. But we check the strength of the membrane sheet, and that indicates the end of the, that's an indicator of how much lifetime you have left on your membrane. And we'll be honest with you, and just let you know that some when we showed these kind of data, so, you know, sometimes the service director wasn't very happy, but at one of the plan, because we're not seeing a very good data. But we'll just, you know, show you what it does. And like Bandon Dunes, Oregon, is operating for 19 years without replacement. I'm not sure, you know, there are some plants that operates really long, but you know, we're going to come, you know, we're not going to come into your plant and say, oh, you're about 10 years, got to replace. No, we're going to check it. If it's good, you guys can operate more and more. And there are a lot of plants operating pretty long years, and there are some plants that have replaced as well. And keeping the membrane to a longer lifetime, and please do not over aerate, or you have a lot of relax time. If you relax a lot, that could, you know, be a little bit more stronger to the membrane. Higher mixed liquor, high viscosity can be a little bit more difficult. And also, if you do chemical cleaning like every week, or every 3 days or something like that, it's going to be intensive. It's not going to help the lifetime. So we want to help you to maximize your lifetime and make it easier operation for the membrane. So that's the that was about the basics. How much time I got left? A little bit more, maybe. So I think I'm on time. If you have any questions, I think you can ask on the chat or send some emails to Taz, or maybe, you know, I'm not sure if you have time of that afterwards, but yeah, please write down your questions if you have. Now, in case of troubleshooting, this is a plant in West Coast that I had to go during the Christmas season. I'm not sure why, but I do very often get a call on a Friday night. I went to a plant 2 hours south from where I live 2 weeks ago on Saturday. I had a phone call on Friday night during the dinner time, but you know, things happen on the weekends and Christmas and holidays. But anyway, we had a very weird trend at this plant, and you can see the permeability is going up and down, the TMP is all over. And so, yeah, I had a, you know, long phone call, and the operator wanted me to come over right away. It was the end of December, but I just went down there and spent almost about 12 hours at the plant, from 9 a.m. to 9 p.m. and try to figure out what was going on. This plant, as you can see, you know, it's a little weird, but a lot of things was just happening with the data all over. The trend was not consistent, you know, and so here's the question, you know, again, you know, if this is in person, I would ask everyone, but how can we make it better? If you were the service guy of Kubota Corporation, what would you do? Any thoughts? What would you check? How should we, you know, help this operator in this plant, you know? So again, if it's in person, you know, because we have like 100 people in this conference, I think, today, and everyone have a lot of experience, I believe. So I'm sure you guys can help each other as well. And so I wanted to do this interactive, but you know, it could be a little difficult. So I'll just continue to go on. Again, I do apologize for, you know, this virtual setup, maybe not completely, you know, ideal for everyone, but please think about this. You know, if you go to this plant, how would you help if you were in Kubota's, you know, if you were a Kubota service person? You know, you're seeing this, you know, same plant. So data's all over. You know, when you look at the data of low, you know, the first call was came in as a low permeability. You know, hey, I have a very low permeability, you know, very high TMP. You know, TMP is all over, but it's very high in TMP and low in permeability. What can I do? You know, and he showed me these data. So the first thing I did was, okay, show me your data. The operator texted me these data. Here's what's happening. You know, and so the first thing I noticed, you know, is that, hey, it doesn't really look like a fouling of the membrane, but it looks like more like a data playing around all over, you know, to be honest with you. But low permeability can be caused from all different kind of things. You know, it could be a membrane issue, it could be set point issues, it could be some instrumentation issues. Yeah, so there could be a lot of reasons. And I want to, you know, if you have came to my operator workshop in the past, I know you have seen this, so you may know the answer, but typically I do this hangman, you know, a quiz, and ask the operators to choose any alphabetical words to fill in this 1, 2, 3, 4, 5, 6, 7, 8 letter hangman test, you know. And again, I always like to do this in person and ask every operators to choose an alphabet, and if that fills or not. If you couldn't make it, fill it in, you know, the hangman will have, I mean, I did this at elementary school when I was young, but I don't know if you use this right now or not, but the answer is 1 by 1, you know. I'll just write it down, 1 by 1. So I always want to very, very much emphasize this word 1 by 1. This is one of the very key part of my, you know, of this session of troubleshooting, is when you have troubles, typically one trouble causes another trouble, and it's going to get very, very complicated, and you never know what's going on, and you get in panic, you know. Oh, all these things happening, the TMB's all over, chemical cleaning is not working, or whatever. Let's, you know, any of these things will have reasons, and there's got to be a reason. There is a reason. It's not the magic. It's not an illusion. It's a technical thing. There's always a reason. We just got to, you know, do things 1 by 1 to find out what is causing these things, right? And so we have an approach called fishbone approach. I'm sorry, I'm originally from Japan, and you know, Japanese people like to eat fish quite a bit, you know, like this, you know that sushi restaurant, or it's a fish, but you know, what this means is, you know, let's figure one bone at a time, one thing at a time. There's always a reason. If you try to fix multiple things at the same time, and if things improve, you may not know what really was the cause of that if you fix multiple things in one time. So let's not do that. Let's figure out one at a time. This is an issue or not. It sounds like it's going to take a while, but eventually that's the fastest way when you have very difficult issues. Okay, what we typically ask, okay, well, let's just make sure, you know, what's the mixed liquid quality? You know, if you have low permeability, what's the mixed liquid quality? You know, again, this filterability testing is a great indicator. This plant has like almost like 30 milliliter in 5 minutes. It's a very good plant. This is a plant that I visited in Washington. I think this is Arlewood, Washington, but we had like 6 or 7 milliliter when it was very bad. I think it only had 3 to 5 milliliter in 5 minutes. And so such quality was very poor in some of the cases compared. If you compare 5 minutes, and if you have a plant that only have 5 milliliters coming out in 5 minutes versus 30 milliliter, you're gonna have a lot more higher TMP. So this is one thing we check. Make sure that mixed liquors is okay. Any of the fouling materials, foulants coming into the plant. Sometimes we do turbidity check of the filtrate of this filterability test. So we take this filtrate and do filterability testing. Some plant had a very cloudy situation. That means you have a lot of soluble COD, and I kind of explained the soluble COD as leftover pizzas. If you have a lot of food coming in, if you have a lot of pizzas coming into the plant, and if you don't treat that properly, if all this biology was dead, let's say, all this pizza is going to be left over. Soluble COD is going to be higher. Organic material is going to be higher. And you see a very white cloudiness, and that means the biology is not properly treating. So those leftover pizzas are going to start fouling the membrane. Inorganic fouling material like calcium can scale the surface of the membrane. So this is a pretty bad plan, but it's another material that can cause high TMP and low permeability. Just need to do the acid cleaning if you have that. So sometimes we'll check the membrane cartridge itself. Check the, we cut the membrane sheets into pieces, and we do a flow rate testing, and just check, okay, membrane sheet based, what's the flow rate that can we have with this membrane compared to new membrane? The flow rate can be like 10% when it's fouled, 5%. So when you see that, we dip this membrane sheet into a chemical, like let's say sodium hypochlorite, and then we do another filterability testing, and we check the flow rate. And compared to the new membrane, it will recover up to 70 or 80 or 90%. If you see an 80% recovery, you're pretty much good. It's just fouled. You have to do chemical cleaning with sodium hypochlorite. Now, if sodium hypochlorite doesn't recover very well, then we could try an acid cleaning after sodium hypochlorite and see how much that will recover. We could do that in other way around. We could do acid dip first, and then sodium hypochlorite clean next, if just sodium hypochlorite is not cleaning your membrane. Some plants, we have to optimize the chemical cleaning process, and so if you have a very difficult in cleaning, and if the recovery is not very well, please talk to us, and we'll we'll do all these testing for free. And so these testing, we won't ask you to do it. We can just do it on our own for this destructive testing. But we want to optimize your chemical cleaning process, and so we want to help you guys. So let us know if you have a difficulty cleaning your membrane sheet. Yeah, this is a plant in New Mexico that we did multiple chemical cleans. After the original membrane is red, and it showed almost no filterability flow rate in this testing. When you did oxalic acid, the COOH2 is oxalic acid, it recovered almost nothing. And then after that, when we did sodium hypochlorite clean, it recovered. Oh, sorry, yeah, we did the sodium hypochlorite, NaClO is the sodium hypochlorite first, and it did not recover. And then we did oxalic acid, it did not recover. And after that, we did another sodium hypochlorite, and we recovered this. The same membrane, we did hydrochloric acid after sodium hypochlorite, but with the sodium hypochlorite or hydrochloric acid, didn't clean. But after doing sodium hypochlorite, hydrochloric acid, and another sodium hypochlorite, it cleaned. Another run of the testing, we did oxalic acid clean, did not recover. Sodium hypochlorite clean, after that, it recovered. This one, we did sodium hypochlorite, and then another sodium hypochlorite for 22 hours, but it didn't clear. And then acid after that, didn't clear. In this case, so it's all same membrane from one plant. Oxalic acid, 2 hour, didn't clean, 22 hour, didn't clean. And after that, we did sodium hypochlorite, it cleaned. So with doing all this optimization testing, we figure out that there's a common thing in these testing is whenever we do acid, and then after that, when we did sodium hypochlorite clean, it cleaned in that order. If we do sodium hypochlorite first and acid second, it did not clean. But whenever we did acid first and sodium hypochlorite second, it cleaned significantly at this plant. So sometimes there's an order for the chemical cleaning process. You have to do, at this plant specifically, you have to do acid first somehow, and sodium hypochlorite second to clean the membrane. But again, in the bottom end is sometimes the chemical cleaning process have to be optimized at some of the plants. Well, you know, most of the plants, I would assume 90% of you guys are just cleaning with sodium hypochlorite, and that's good. If it's showing a good recovery, then you're okay. But if you're having a difficult, we had a golf course that had a big party that fouled the membrane and couldn't recover very well, that tried acid first and sodium hypochlorite second, it cleaned very, very well. We had another plant that have a very hard water that used acid first and sodium hypochlorite second. It worked pretty well. So there are some plants that needs to use acid as well, but most of the plants I think use the sodium hypochlorite. Most of the plants, I think that's good. I'm talking about the troubleshooting. This is not a typical process, but if you need the help, please let us know. We can optimize your chemical cleaning process. We did a cartridge testing at some of the plants as well, not just the sheet, but we checked some of the cartridge. Normally, we don't do this anymore very often. We check the sheet only, but if you want us to check each individual cartridges, we can do this. We check the permeate pathway, the tubes, manifold, the pipings, airlocks. This plant is a plant in Idaho that had a lot of calcium scaling inside the tubes that was plugging the membrane, that was plugging the permeate pathway. Again, we had to do acid clean to kind of clean this up. Yeah. And we also checked these oh, I thought I had airlock, but I have airlock in some other places maybe. We also want to check the diffuser again. I think I talked on this basic, but please check the air pattern. If you have a cover, maybe once a year, you might want to take that cover off and check the air pattern. Sometimes they check the diffuser, you know, but you can check that air pattern. Please check the fine screen, especially if you have band screen that you have all these chains at the very corner. There could be a lot of gap in these chains that can bypass a lot of waste, sewage. We have a very old bar screen. I would recommend you to upgrade the fine screen to a better drum screen or something, but this is a plant in Alaska that we had a lot of openings at the corner that we had to seal. This is outside fed drum screen, and there was a lot of gap in between the drum and this scraper. And you know, maybe at the very beginning when you start the operation, this looked a lot better, but after years of operation, this scraper was bent and we had a lot of gaps. Yeah, wanted to show one presentation from Paulding County. They did operator workshops a couple years ago, and they had a screen, and after the fine screen, they put this little bar, and in like 5 minutes, they figure out that so many things was going, you know, was caught. And so they checked their band screen, and at the very bottom of the band screen, they found this. The bottom metal piece was completely fallen off. So these are the metal piece, and you can see that it's completely fallen off to the bottom. So they were bypassing these this fine screen for quite a bit of times, and they found the membrane being pretty messed up and dirty at the plant. So they upgraded the fine screen recently. It took about 10 years to do this, but I visited the plant in 2011, 10 years ago. Recently, they finally upgraded the fine screen. So you want to check that fine screen, and I'm going to wrap up very soon. But yeah, another things is you want to check all these airlock or chemical cleaning line. You know, sometimes when you do chemical cleaning, there's a pressure relief, and the chemical could be bypassed to those and not getting into the membrane. So you might want to check if pressure release is not discharging the chemical direct. There's also an airlock that could happen, and I always show the same video, so this is a plant that had a lot of air, and we made the permeate piping into a clear tube so that we can see the air. But when you have a very high TMP, you can see a lot of air in the piping lines. And so you might want to reduce that, you know, and get the TMP right. Now, there was a plant that you could also have, you know, instrumentation issues. You know, you had some water leakages at some of the plant that can cause a very weird trend. So this is not the membrane issue, but, you know, the trend itself, instrumentation, wiring could flood it up with water, and that could cause a very, you know, weird trend, like the one that I showed in the very beginning. So there's a lot of things, but again, the key things is to figure these things one by one. Again, the key word is one by one. That's the important part. But if you have difficult troubles, just call us, okay? These are all these phone numbers, our cell phone. These are all cell phone numbers. Please take a note. Myself, Brian covers the Center United States. Kevin covers the Northeast. Damone covers the Southeast. I cover the West Coast. And Taz and Roscoe is the service guy that is available anytime. And so please take a note of these phone numbers wherever you are. We can, you know, any of us can, you know, work on, but if you have any issues, just let us know. We'll figure it out. We want to, again, our bottom end is we want to help your plant operate properly, and that's the bottom end. We want your MBR to be a good operating plant, so that you know, it's a good for you guys and good for us, and it, you know, eventually, you know, it will make your operation great and successful, and our business successful. It's a win-win situation. But yeah, we want to help you guys, and that's the ultimate goal. And that's why we're doing these workshops. So, you know, please take a note of these cell phone numbers and call us whenever you need us, as my conclusion. This is another plant in Washington. Yeah, we love the mix sticker. I do love to get into the tanks. We'll work with you guys, and yeah, these operators are great friend now, and you know, I hang out pretty often. But anyway, maybe I'm not sure these guys are on this call today or not, but yeah, they knew me a lot. But so that's about it for my presentation. Thank you very much.